Have you ever wondered how your favorite app remembers your preferences, or how your shopping cart keeps your items even after you've logged out? It's all thanks to a concept known as data persistency. Without it, we'd be living in a digital world of constant amnesia, where no action has a memory and no process has a past. So what's the big deal about data persistency? Well, it's fundamental to almost every software application we use daily. Think about that online shopping cart. You add items, browse other products, maybe even log out and come back later. Yet, your items are still there, waiting for you. That's data persistency in action, providing a seamless user experience by maintaining state. Picture this. You're working on an important document when suddenly a power outage strikes. You reboot your system and, to your relief, find your work intact. That's data persistency again, saving the day by allowing data recovery after system failures. Now consider a business trying to understand its performance over the past 5 years. It needs historical data for that, right? Data persistency comes to the rescue once more, enabling long-term data analysis by storing data in a stable, lasting manner. This helps businesses make informed decisions based on trends and past data. But it's not just about business intelligence or recovering lost files. Data persistency also enhances our daily digital experiences. When your music app remembers your favorite songs or your navigation app recalls your frequently visited places, that's data persistency improving your user experience by maintaining personalized settings across sessions. In essence, data persistency is like the memory of our digital world. It allows applications to remember, to learn, and to become more useful over time. It's a silent, often overlooked but absolutely essential component of our digital lives. So, as you can see, data persistency plays a crucial role in ensuring a seamless and personalized user experience. Now that we've established the importance of data persistency, you might be wondering, how is data made persistent? To answer that question, we need to delve into the variety of methods and storage options used to achieve data persistence. One of the most common methods is through the use of file systems. Data can be written to and read from files on a disk. This is managed manually through creating, reading, updating, and deleting files. Most operating systems come with built-in support for these file system operations, making it a readily available option. Yet, file systems might fall short when it comes to handling larger volumes of data or ensuring robust data integrity. This is where databases come into play. Whether you choose SQL or NoSQL databases, they provide more complex structures to store, query, and manage data efficiently. Databases not only handle larger volumes of data, but also provide robust data integrity features and often include mechanisms to ensure data consistency and recoverability. But what if your application needs to manage large amounts of unstructured data or requires the data to be accessible across multiple geographic locations? This is where cloud storage services like Amazon S3, Google Cloud Storage, and Microsoft Azure Storage come in handy. They provide highly scalable and reliable environments for storing data, ensuring data persistence across distributed systems. In the realm of web development, data can also be stored in the browser using local storage or session storage. Local storage is persistent across sessions until explicitly cleared, while session storage persists data only for the duration of the page session. This method is particularly useful for maintaining user settings and preferences across sessions, enhancing the overall user experience. So, in a nutshell, the method you choose to make data persistent depends heavily on your specific needs and the volume of data you're dealing with. From file systems and databases to cloud storage and local or session storage in web development, each method has its advantages and use cases. Different applications might require different methods of data persistence based on their specific needs and volume of data. The concept of data persistency is implemented using various tools and technologies. In the realm of relational databases, we have stalwarts like MySQL, PostgreSQL, and Oracle. These tools excel at managing structured data with complex relationships. They offer robust features to ensure transactions, concurrency, backups, and data integrity. They're like the reliable, sturdy workhorses of the data persistence world, ideally suited for applications where structured data and complex relationships are the norm. On the other hand, NoSQL databases such as MongoDB, Cassandra, and Redis offer a more flexible approach. They support flexible data models and are better suited for scenarios with large volumes of semi-structured or unstructured data. If you're dealing with an application that requires high performance with low latency, these are your go-to tools. They're like the nimble, versatile speedsters, ready to handle whatever you throw at them. But what if you're a developer who doesn't want to deal with complex SQL queries directly? Enter Object Relational Mapping, or ORM technologies. Tools like Hibernate for Java, Entity Framework for .NET, and Django ORM for Python abstract the database interactions in an application. This allows developers to work with data as objects, simplifying the process of data management. It's like having a personal translator, bridging the gap between your application and the database. Each of these tools has its strengths and ideal use cases. MySQL, PostgreSQL, and Oracle shine when dealing with structured data and complex relationships. MongoDB, Cassandra, and Redis excel when flexibility and speed are paramount. ORM technologies like Hibernate, Entity Framework, and Django ORM are superb when you want to simplify database interactions. It's all about understanding your needs, the nature of your data, and the specific demands of your application. Like choosing the right vehicle for a journey, selecting the right tools for data persistence can make all the difference in achieving efficient data management and optimal application performance. Choosing the right tools and technologies for data persistency is crucial to ensure efficient data management and optimal application performance. Implementing data persistency, however, comes with its own set of challenges. One of the most common is maintaining data integrity. This means ensuring that data remains accurate, consistent, and reliable over its entire lifecycle. For example, if multiple users are accessing and modifying data concurrently, there's a risk of conflicts or inconsistencies. This is where the concept of atomicity comes into play, meaning operations are treated as a single, indivisible unit, either fully completed or not executed at all. Another challenge is handling concurrency. When multiple users or processes try to access and modify data at the same time, it can result in inconsistent data or conflicts. Concurrency control mechanisms, like locking or timestamping, are crucial to prevent such issues. Locking ensures that only one user or process can access data at a time, while timestamping keeps track of the order in which operations are performed. Data security is also a significant challenge. Implementing proper security measures is critical to protect sensitive data from unauthorized access or breaches. This involves limiting who can access the data, what they can do with it, and monitoring their actions. Now let's talk about best practices to overcome these challenges. To maintain data integrity, it's essential to use transactions. Transactions bundle multiple operations into a single unit of work, ensuring that either all operations are completed successfully or none at all. This helps to keep the data consistent and reliable. Regular backups are another best practice. Backups help to recover lost data in case of a system failure or data corruption. It's recommended to perform regular backups and test them regularly to ensure they work when needed. Access controls are also vital for data security. They limit who can access the data and what they can do with it. This includes using authentication to verify the identity of users, authorization to determine what they can access, and audit logs to monitor their actions. By following best practices, developers can effectively manage these challenges and ensure reliable and secure data persistency. And remember, the goal is not just to store data persistently, but to do so in a way that is efficient, reliable, and secure. Let's take a moment to recap what we've learned today. We dove into the concept of data persistency, understanding it as the ability of data to remain stable and unchanged, surviving beyond the lifespan of the process or session that created it. This characteristic is fundamental to software applications that need to maintain state or user data across sessions, enhancing user experience and supporting data recovery, among other benefits. We looked into the different methods of achieving data persistency. We explored file systems, where data is written to and read from files on a disk. We also delved into databases, both SQL and NoSQL, which provide intricate structures to store, query, and manage data efficiently. Additionally, we discussed the modern trend of cloud storage services like Amazon S3, Google Cloud Storage, and Microsoft Azure Storage. And let's not forget local storage and session storage in web development, which allow data to be stored in the browser. In our journey through the world of data persistency, we also uncovered a variety of tools and technologies. For relational databases, we discussed tools like MySQL, PostgreSQL, and Oracle, which are great for managing structured data with complex relationships. For NoSQL databases, we highlighted MongoDB, Cassandra, and Redis as they support flexible data models and are ideal for handling large volumes of semi-structured or unstructured data. We also touched on object relational mapping technologies, which abstract database interactions and allow developers to work with data as objects. Finally, we discussed the challenges and best practices in data persistency. We emphasized the importance of choosing the right method and tool based on the specific needs of the application and the nature of the data. We also highlighted how crucial it is to ensure data integrity, consistency, and recoverability in all data persistence operations. Remember, in the world of software development, data persistency isn't just a concept, it's a necessity.